Welcome to Chapter 3. This is 3.1, What is a rational number? By the end of this lesson, you should be able to identify what a rational number is, give me a definition, give me several examples both in fraction and decimal form, as well as be able to take and put them in order from least to greatest or greatest to least. So that's our goal. So in this lesson, we're going to talk about the rational numbers. Let's start at the beginning. When you were first introduced to numbers, you were introduced to 1, 2, 3, 4, 5. These were called the natural numbers. They started with 1 and incremented by 1 each time. You're taught with counters. And then we had to have the concept of 0 introduced to you, and that is what happened. We called that whole numbers. And then after that, we went to the negative numbers. At this point in time, there were no rational numbers involved at all. All you had was the whole numbers, either positive or negative. Now, rational numbers are the decimals and the fractions. When written as a fraction, a rational number can be placed in m over n, but n cannot be 0 or you get an undefined error. Another more popular definition that helps is that when you take a rational number and it's in decimal form, then it will either repeat or it will terminate. So if you can put it in a fraction, or when it's decimal form it repeats or terminates, that's a rational number. So let's take a look at some examples here first. This is one of the things I want to cover because it helps you when you're doing some of your algebra later. If I've got 1 over 4, negative 1 over 4, 1 over negative 4, and a negative 1/4 here, which one of these are equal? So just think about it for a second. Now, you'll notice that this one is the only one that doesn't have a negative in it in either place. This one has a negative here, a negative there, and a negative there. So you take a look, and I change them into decimal form. 1 divided by 4 is 0.25. Now it's a positive divided by a positive, which means your quotient, your answer to a divide question, is going to be positive. Now, this is a negative 1 divided by 4. A negative divided by a positive gets a negative, and 1 divided by 4 is 0.25. And you can see the other two also come out to be negative 0.25. Now, if we take the ones and list the ones which are equal, you'll notice that we chose the ones which were all negative. Well, how can they be the same? Well, here's a way for you to figure it out. If you think of multiplying negative 1 over 4, and you multiply it by 1, where I put the 1 in the form of a number over itself, and I'm going to choose negative 1 over negative 1. And negative 1 divided by negative 1 is 1, so it is actually 1, so I'm multiplying by 1 and not changing it. But look what happens to the negative. Okay? If this is negative and that's negative, a negative times a negative is a positive. And a positive here times this negative, positive times a negative gives you negative. So if you take a look at that, you'll notice that the 1 over negative 4 and the negative 1 over 4 are the same thing. It's just a different form. So how is 1/4 and the rest of them different? Well, they're the same in that they're the same distance from 0, 1/4 to the negative side and 1/4 to the positive side, but they're on opposite sides. These are called opposite fractions. In a decimal form, obviously we call them opposite decimals. So 0.25 and negative 0.25 would be referred to as opposite decimals. Okay, so here's a chance for you to try something. I want you to take 3 over 4, and I want you to name its opposite fraction. Same for 1 over 5, and the same for 4 over 5. Okay, here we go. All you have to do is change the sign. So 3/4 and negative 3/4, 1/5 and negative 1/5, and 4/5 and negative 4/5. These are all opposite fractions. And you'll notice that when you combine them, you always get 0. So take a look at the three opposite decimals. 1.5 would be negative 1.5, 0.4 would be negative 0.4, and 23.2 would be negative 23.2. And when you put these together, you'll notice that they will also form 0. So mixed numbers can also be rational numbers. And let's go back and talk about what a mixed number is for a second. A mixed number is a number that has a whole number, and then it has a part number with it. So we're going to be working with, there we are, here's our definition. When you have rational numbers which are written as a fraction 1 m over n, a mixed number would be 1 and m over n. Now you can see down here 2 and 3/4. That's a mixed number. Now mixed numbers could be whole numbers and fractions, or they can be whole numbers and decimals. So any number that is a mixed number, can you write it as a fraction like m over n? Well, you can, because we can change this 2 and 3/4 into what we call our improper form. Remember, it's 4 times 2 plus 3, and that gives you a sum, sorry, 8 plus 3, which is 11. Now the denominator stays the same. Now 11 over 4 is in the format m over n. So that means that 2 and 3/4 is in fact a rational number. So are all mixed fractions rational numbers? The answer to that is yes. Every mixed number can be changed into its improper form. So if it can be changed into its improper form, it's going to be m over n, a single number over a single number. And that is what we call a rational number. Well, let's look at decimals. If I have 1.2, the first thing we can do is, can you change 0.2 into a fraction? Well, this is 1 and 2/10, right? So 2/10 reduces down to 1 over 5, divide both by 2, and then we can take and change 1 and 1/5 into an improper fraction also. 5 times 1 plus 1 giving us 6 over 5. So if I can change this into a fraction, and all fractions are rational numbers, that means that all decimals are rational numbers if they terminate and or repeat. So is this one a rational number? Yes, it is. Do you think all mixed decimals can be written as fractions? Well, that depends. If they are a mixed fraction, so mixed decimal where the decimal repeats, you can put the repeating period over 9 and turn it into a fraction. If it's a terminating decimal, then you just put that over the power of 10 that's required to turn it into a fraction. So which of the following are rational numbers? Well, this is already in fraction form, so this one is. This one repeats, so this would be 1 and 3/9, which could reduce. 4 and 5/7 turn it into a mixed fraction, improper fraction, sorry. Whole number and integers are automatically rational numbers, and this is a terminating decimal, which is also a rational number. So the question here is, the answer to this one is all of these can be written in fraction form. And if they can all be written in fraction form, that means they are all rational numbers. Okay, let's take a look at some number lines. A number line is an excellent way to show rational numbers. On both sides of the zero, you've got negatives on the left and you've got positives on the right. So what I want you to do is I want you to pause the recording and see if you can place all of these on the number line. Now I've been nice to you because I've put all of my increments in by 10, so you should be able to do it fairly easily. So pause the recording and place these onto this number line, please. All right, so here we go. Starting off with negative 1.1. What's a negative, which means you go to the left, and the 0.1 is 1/10, so there is negative 1.1. 1.1 is one that is actually, I meant to fix this one, but this one is, I'm sorry, it is correct. I thought it was wrong. Here's your 1, and here's your 1/10, so that's 1 and 1/10, which is 1.1. The next one is 1.3, so starting at 1, go to 3/10, 1, 2, 3, there's 1.3. 0.04 is 4/10, so 1, 2, 3, 4, there's your 4/10. Negative 0.5 is negative 5/10, so 1, 2, 3, 4, 5, here is negative 5/10. And 0.45, this is negative 45 hundredths, okay? Or you can think of it as 4/10 and a half of 1, all right? So negative, so this is positive, so you should have 1, 2, 3, 4, and then you have to go halfway to the next one, and that's where your 0.45 is. So if someone asks you, why is negative 1.1 less than 0.5, then it's really simple, because the farther you go to the left on a number line, the smaller the number it is. The farther you go to the right on the number line, the greater it is. Since negative 1.1 is farther to the left than negative 0.5, that means this one is smaller than that one is. A classmate tells you that 1.1 is greater than 0.4 because 1.1 is larger than 0.4. So how would you correct your classmates' thinking? Well, to do this, you have to go right back up to what we just said here. Okay, negative 1.1 is on the left-hand side of the 0. That means it's going to be less. Anything on the left is always less than on the right. All right, so this zero point 0.4 is a positive. This one here is a negative. So there's your negative 1.1, and here's your positive zero point 0.4. Since this one's on the right and this one's on the left, this one has to be greater and this one has to be less. Remember again, the farther left you go, the smaller the number it is. The easiest way of thinking about it is the greater the negative, the smaller the number. So there you go right there. The numbers on the left of a number line are always less than the numbers on the right. Since negative 1.1 is on the left and 0.4 is on the right, 0.4 is greater. Okay, so what I'd like to do next is take a look at how do you find numbers between 0 and 1. Because we think of 0 and 1 as being right beside each other, but you don't realize that 0 and 1 are whole numbers. There are a whole bunch of fractions between them. In fact, there are an infinite number. So if you think of 0 as being 0.0, and this as being 1.0, we can have 0.1, 0.2, 0.3, 0.4. We could have a whole variety of them only in the tenths. If you want to get even more, you could go with 0.11, 0.12, so 1200s, 1300s, and 1400s. Here again, take a look at this one. This is negative 5 tenths. So between here, I can have negative 1 tenth, negative 2 tenths, or negative 3 tenths. As long as I don't mention 0.5 or negative 5 tenths, I'm okay. Again, this could be negative 12 hundredths or negative, 13 thousandths or whatever. It doesn't matter as long as it's between the 0 and the 0.5, it'll always be the correct answer. Now, 1.1 and 1.3, again, think of this as being 1 tenth, and this as being 3 tenths. So between 1 tenth and 3 tenths, I can choose 1.2, which is the obvious one, or I can think of this as being 11 hundredths, or 1.11. This could be thought of as 1.20, so 11 and 20 and 29, they are all between 10 and 30 here. So we'll give you a chance to think about that. Here we go. How about this one? Again, I have to be less than a tenth. And the only way to be less than a tenth is to move into the hundredths. So this could be 0.01, 0.05, 0.09, 0.1, sorry, 0.09. No, I guess you can't place 0.1 there, because if you place 0.1 there, it would be equal. But I could go down to thousands and have 0, 1, 0, and think of that as being a 10, this being a 50, and this being a 90, and anything between those would also be acceptable. All right, let's try with some fractions. Pause the recording and see if you can place all of these on this number line. All right, let's take a look. All right, our first one is 2 1/4. It's positive, so it's going to be on the right of the 0. Since it starts with 2, I could go to the 2, and now I've got to get to the quarter. Now, I've been very kind to you because I've put only quarters in here. There's 1, 2, 3, 4 divisions. So I've got to go 2 and 1 more quarter, so there's your 2 1/4. Negative 1 1/2, you start at 0, you go to negative 1. Now a half is 2 quarters, so 1, 2, there's your 2 quarters. You have to think of equivalent fractions for that one, or it's halfway between negative 1 and negative 2. Now, next one's negative 3 quarters. Well, here's 0, and negative 3 quarters, there's 1 quarter, 2 quarters, and 3 quarters. Now, let's take a look at 3 quarters. Again, 1, 2, 3, there's 3 quarters right there. Negative 1 3/4, you go from 0 to negative 1, and then you can count off your 3 quarters, which puts it right here. Negative 5/8, you start with 0. You can't go to negative 1 because 5/8 is less than 1. So we're going to go and think of this as being an eighths. A quarter is 2/8. So that's 2/8, 4/8, and one more would be 5/8. Okay? And 2 1/3, this one actually kind of messes up because you can't use your quarter markings here. You've got to think of between 2 and 3 as being divided into 3 equal parts, and the 2 1/3 is just the first part, which is, or the first increment there. So that's 2 1/3. All right. Now, to do rational numbers in fractions, this one becomes a little more difficult. It's easiest, though, if you take and turn the first one into its equivalent fraction with a larger denominator. So think of this being multiplied both by 2. That gives you negative 6/8. and this one would be 6/8. So I've got to be between negative 6/8 and negative 1 and 6/8. So anything 7/8, negative 7/8, negative 8/8, negative 9/8, as long as I don't get past this one, I'll be okay. All right, now this one here, 3/4 and 2. Turn this one into quarters. That is 8, oh, sorry, yeah, 8 over 4. So this would mean anything but like 5 over 8. Um, oh, I guess I just went to 1 here. This is easier, I guess. Don't have to be that complicated. You can choose 1, 1.5, 1 1/4, 1 1/3, 1 1/5, as long as I don't get past 2. So any fraction with the whole number 1 and any a fraction at all attached to it would be correct. Now 2 1/4. What I've done here is I've gone to sixteenths. So this is 2 and 0/16, and this is 2 and 4/16. I'm creating them by their equivalent fractions. So 0/16 and 4/16 means I can have 1/16, 2/16, and 3/16. If I want to have more, I could choose a different denominator to create the equivalent fraction to. I could have gone to 30 seconds. So this would be 2 and 0/30, and this is 2 and 4/30, and that, sorry, 8/30, and then you could go that way. Now the last one, negative 3/4 and negative 1/2. Here we go. I'm changing my equivalent fractions all into twelfths. So multiplying this by 3, that is negative 9 over 4, sorry, over 12. And this one would be, since we're in twelfths, 6 over 12, negative 6 over 12. So anything between 9/12 and negative 1 and 6/12 would be correct. Now if you change negative 1 and 6/12, you get 18/12. So there's quite a few numbers in here you can mess around with. Negative 10 all the way through to negative 18 over 12. Okay? Now, ordering rational numbers. When numbers are all in the same, in decimal form, it's kind of easier if you just sort of equivalent them out to the same number of decimals. And I chose to do thousands here. So I rewrite this as 0 and 250, 3 decimal places. I put this in 3 decimal places. I put this in 3 decimal places, etc., and etc. Now, since they have all got zeros here, here, and here, I can just compare the decimal parts. These ones and ones, they can be compared relatively easily because that's a negative one, that's a positive one. Now putting them in order from least to greatest, remember the larger the negative number, the smaller it is. So the smallest number is going to be negative 1.6. Okay, that takes care of that one. Now which other is the negative which is greater? That is negative 200. And now I've got rid of my negatives. I can start working with my positives. Now this is 250, this is 255, so this one comes next, and then the 255, and then finally I can do the 170. Okay, so here's what I want you to try. So pause the recording and put them into their proper form. All right, first things, I'm going to choose to put everything in 2 decimal places. So this becomes 69, or stays 69. This becomes 30, that becomes 20, that stays as 27, and that stays as 33. So now to put them in order, I have to look for the largest negative. Now this is 233, that's 230, this is the largest negative, which means this will be first, then this will be second. Now I've got my positives to deal with. I'll just go to the next page here, and you can see what I've got. There's 233, and now the negatives, so the positives, I guess, would be next, 0.69. And then greater that is 2.20, and then 2 and 27. So think of this as 220, and that is 227. It's easier to see that this here is larger. Okay, fractions. The easiest way to do fractions is to convert them all into decimal form, and then make sure that they have the same number of decimals. Now remember, to change a fraction into a decimal, you have to divide the 4 by the 5 by the 7, and you'll get all these numbers here. Now when you change them into their same number of decimals, you basically makes it a little bit easier for you to do it. Okay, I guess I've clicked the problem. Made a mistake here. I went too fast. So now the largest negative is negative 4.2, so that goes first. Then comes negative 4. Then comes the next one after that would be the negative 0.8. And now we can switch to the positives. 71, 75, and 233. 71 is next. 75 is next, and 233 is last. Now, you have to write them back in their original forms. You were told to put these fractions in original form, not these decimals. So rewriting them in their original form, just match up the fractions and the decimals that you've created here. There you are. Okay, now let's have you try this one. So pause the recording. Oh, sorry, this is different. This is another way of doing it, and one I do not recommend. You have to find the lowest common denominator, and you put them all into equivalent fractions. Now, this lowest common denominator, I actually cooked these so that they'll all be 24 so the numbers wouldn't get so large. So 3 becomes 24 by multiplying by 8, so this becomes negative 16. I'll just get rid of this. All right, 1 over 4 becomes 6 over 24, and you can see they're all basically put into their fraction form. Now, since they're all in 24s, all I have to do is to place the numerators in order. So the largest negative is the smallest number, so negative 16 goes first. Then comes negative 12, which is a negative sign there. Then there's a negative 10, and then there's a 6, a 9, and a 20. Okay, now remember, put them back in their original forms. And there you have them placed in order. All right, so the last part is to put decimals and fractions together. In the textbook, this is the one that they do. They say, order the following numbers and place them on a number line. All right, so first we're going to convert only the fractions into decimals. Now, 10 divided by 3 is negative. This should be a negative here. Okay, and then everything else turns out like this. Now place them in order, and you can see I made a mistake here. I had a negative, but I dropped it. So this negative 3.33 should be between these two right here. All right, that's what happens when you drop a negative. It even happens to the best of us. Okay, and when you put them on the number line, again, this is in the wrong spot. This should have been over there between these two. There's 3, and there's actually 3.3 is right there. So that's where your negative 10/3 should be. But everything else is in order according to what we figured out up here. Okay, so now the last part is for you to take a look at the fraction line and tell me what fraction or rational number is represented by the numbers. Now, in order to do the A, you have to figure out how many divisions there are. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means that each division is a tenth. Now don't be fooled, this is negative 3 and this is negative 2, so don't count from the left. So for A, it's going to be 2, negative 2, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So A is negative 2.8. B is going to be negative 2.1, 2.2, 2.3, 2.4, and C will be negative 2.1. Okay? So how did I decide what the decimal portion was going to be? You have to count the increments in here, the spacings, to find out. Because if this is tenths, it makes it really nice. If it's ninths, you'll have to make sure you go and put everything over a 9 and turn it into a fraction form. Okay, so what fraction does this one do? Pause the recording and see if you can find out what A, B, and C are. Okay. So I've got 1, 2, 3, 4, 5. So these are all in basically fifths. Now 1/5 is equal to 0.2. So that is actually negative 2.2. This is negative 2.2, 2.3, 2.4. This is negative 2.2468, which is right there. And B is 3.246. Now you also could have gone and done negative 2 and 2/5. 1/5. You could have done here could be negative 2 and 4/5. And this one could be negative 3 and 3/5. Either one will work out. Okay? So how did I find it? I counted the marks and I found that there were 5. So then 1/5, 1 divided by 5 is equal to 0.2. So that's why I figured out what each was. This is a 0.2, 0.2, 0.2, 0.2. But I've already explained how you could use a fraction to do that too. Okay, next page. All right. I think you're on your own for this one. All right. Now, let's talk about our increments. We have 1, 2, 3 spaces, which means everything is in a third, or 0.3 repeating, because 1 divided by 3 is 0.3 repeating. So what I'm going to do is I'm going to keep it in thirds. I'm going to keep it in fraction form. So this is 0, so I'm going to the positive side, so A is going to be 1/3. B is on the negative side, so there's negative 1/3, negative 2/3, so B is negative 2/3, and C would be negative 2 and 1/3 there. How did I decide what was going to happen? I counted and found out that they're separated by 3 equal spaces, so that means I'm working in thirds, and I decided to use fractions here. Okay, so now I want you to finish the assignment, and we will see you in the next lesson.